Hi dear students, see here, this is one electromagnetic radiation. Just imagine that it is an electromagnetic radiation. In an electromagnetic radiation, there are some crests and troughs. Crests and troughs. Which one is crest? Which one is trough? This is crest. The peaks are called crests and the depths are called troughs. See here, the distance between two successive crests. What is this? Crest, and this is next crest. The distance between two successive crests is nothing but the wavelength of the radiation. It is represented with lambda. And see here, we can consider troughs also. If we consider trough, the distance between two successive troughs also same thing, that is the wavelength of the radiation. And see here, if one crest and one trough combine together, then we will get a complete cycle. One crest and one trough completely gives one circle. We can call it as a cycle. See here, the number of cycles passing through a given point in 1 second, or you can say per second, is called frequency of the given electromagnetic radiation. Now, in this class, we are going to learn the relation between wavelength lambda and frequency nu. Wavelength is lambda and frequency is represented with nu. It's a nu, okay? And what is the relation between these two things? These two are reciprocal to each other. These two are reciprocal to each other. Nu is equal to C by lambda. Nu is equal to C by lambda. What is C here? C is nothing but velocity of light in vacuum. Velocity of light in vacuum. Based on this relation, we are going to do few numericals on it. Okay, let us start first one. Once you check the given calculation here, the frequency associated with a photon of radiation having a wavelength of 6000 angstroms. Here photon is nothing but energy packet, the packet of energy, okay, in the radiation. And they given wavelength in angstrom and they are asking frequency. What is the relation between frequency and wavelength? Frequency is equal to C by lambda. What is C here? C is nothing but velocity of light in vacuum. What is the value of it? 3 into 10 to the power of 8 meter per second. And here, what is the value of wavelength? They gave 6000 angstroms. 6000 angstroms, in a sense, I can write it as 6 into 10 to the power of 3. 10 to the power of 3 is nothing but 1000. And 1 angstrom is equal to how many meters? 10 to the power of minus 10 meters. Meter cancel. 6 ones, 0.5s, because 6 5s are 30. Here 3 is there, no? 0.5. And see here, by simplifying these two things, we will get 10 to the power of minus 7. This 10 to the power of minus 7 will go up. Then 0.5 into 10 to the power of 8 into 10 to the power of minus 7 becomes plus 7. Then these two, it becomes 0.5 into 10 to the power of 8 plus 7, 15. In maths, you already learned, in a product, if bases are equal, you have to add the exponents. 0.5 into 10 to the power of 15 per second. Per second, in the sense, we can write it as heads. Check the options. Okay, there is no 0.5 here. Then we have to convert that one into multiples of 5. That is 5 into 10 to the power of 14 heads. If you write in terms of multiples of 5, we will get 5 into 10 to the power of 14 heads. Let us check the options. First option itself, it is correct answer. Please once you check this one, and we will move to next one. See here an interesting relation is there, that is relation between wavelength and energy of the radiation. See here, Planck's quantum theory already explained this one, and according to Planck's quantum theory, what is the relation between wavelength and energy? Energy E is equal to hc by lambda. You have to remember that one to find out this one, okay? Once we will check this one. If the wavelength of an electromagnetic radiation is 2000 angstroms, what is the energy in ergs? What is the energy in ergs? See here, what is the relation here? E is equal to hc by lambda. See here, what is the value of Planck's constant? What is the value of Planck's constant in ergs? I mean in CGS system, 6.625 into 10 to the power of minus 27 erg second, and into what is the velocity of light in vacuum in CGS system? 3 into 10 to the power of 10 centimeter per second. And see here, what is the value of wavelength here? They given wavelength as 2000 angstrom. 2000 angstrom in the sense 2 into 10 to the power of 3 into 1 angstrom is equal to how many centimeters? 10 to the power of minus 8 centimeter. Then simplify this one. 2 ones are 2. 2 threes are 6. 2 threes are 6. And see here, 2 ones are 2 and 2 twos are 4 and 2 fives are 10. And see here, 10 to the power of 3, 10 to the power of 8. If you simplify these two things, you will get 10 to the power of minus 5. It will move to numerator position and it becomes positive 1, that is 10 to the power of plus 5. Then here 3 is there, 3 into this one. Approximately we will get 9.9. 3 threes are 9, 3 threes are 9. Just I am multiplying only these two things instead of multiplying all the things. And see here, next one 10 to the power of minus 27. 10 it becomes minus 17. And here 10 to the power of 5 will go up. Then it becomes 10 to the power of 5. Then it is equal to 9.9 into 10 to the power of minus 17 and 5. Then it becomes minus 12. Minus 12 we calculated in CGS system, that's why the unit is ergs. What is the answer here? 9.9. Two options are there with 9.9 and only one is there with 10 to the power of minus 12. What is the answer here? 9.94 into 10 to the power of minus 12 ergs. Okay, please check it. In this calculation, we are going to learn one more relation, that is a relation between frequency and wave number. Okay, and here wave number is nothing but reciprocal of wavelength. We will see how to calculate the given problem based on the relationship. See here, the wavelength of a blue light is 4800 angstrom. Calculate the frequency and wave number of this light. See here the given wavelength of the given blue light as 4800 angstrom. The wavelength lambda is equal to 4800 angstroms. 4800 angstrom. They are asking frequency and wave number. First we will calculate frequency. What is frequency here? Frequency is equal to c by lambda. What is c here? C is velocity of light, and velocity of light is 3 into 10 to the power of 8 meter per second by lambda. They given 4800. 4800 in the sense we can write it as 4.8 into 10 to the power of 3, and 1 angstrom is equal to 10 to the power of minus 10 meters. Minus 10 meters. See here, if you simplify 3 by 4.8, if you simplify these two things, we will get around 6.25. After simplifying these two things, 10 to the power of 3, 10 to the power of minus 7, here we will get 10 to the power of minus 7. It will move up and then it is equal to 6.25 into 10 to the power of 8 into this minus 7 becomes plus 7. Then it is equal to 6.25 into 10 to the power of 8 plus 7, 15. And next what they are asking? They are asking wave number. What is wave number? Wave number symbol is nu bar. Nu bar is nothing but reciprocal of wavelength. Reciprocal of wavelength. See here, what is wavelength here? The wavelength is 4800 angstroms. 4800 angstrom in the sense 1 by, I can write it as a 4.8 into 10 to the power of 1 angstrom is equal to 10 to the power of minus 10 meters. See here, if you simplify 1 by 4.8, it is around 2.08. Then it is equal to 2.08 into this minus 10 will becomes 10 to the power of 10. And here, see here it is in meter inverse. Once you check this one, the relation between frequency and wavelength is frequency is equal to c by lambda, and relation between wave number and wavelength is it is reciprocal. Wave number is equal to reciprocal of wavelength, that is 1 by lambda. And there is a relationship between all these things and energy, that is E is equal to h nu. You can write it as hc by lambda. You can write it as hc nu bar. This is one of the most important relation. You have to learn this relation also. Okay. These are all important relations among different physical quantities related to electromagnetic radiation. Okay, and we will learn few more things in next class which is related to energy. Okay, until then, thank you all of you.